Hello everyone, I'm Xiao Gang. Okay, let's continue looking at our components and collisions. I feel that starting from these few lessons, our course should gradually increase in difficulty. Yeah, it will get a bit harder. Okay, now let's take a look at this. This is a simple ball that can respond to your collisions, and it can also enable this particle effect. Okay, it responds to your input and needs prerequisite knowledge. So how does it do it? It first created a project. We don't need to look at this project, and here it uses our cascade particle system. This is the particle system in UA5. We call it particle system. Should we call it cascade particle system? It's more accurate to call it particle system. As for this particle system, we need to make a forward declaration. We will use it. But note here, what we write is a pointer. We haven't created its ability system yet. Because we are using some new thing, we need to do some includes in the constructor. Obviously, it uses a spring arm, it uses a camera, it uses our sphere collision box, then our particle system, and then there's his favorite construct helper. This thing, it's used to find blueprint assets. And then here, he first creates a root node, obviously here. He didn't create a scene component. As the root node, he directly uses our physics reactive to perform this sphere that generates this collision, made into a root node. This sphere component thing, obviously this place, he made a initialized sphere sides, and at the same time specified its collision type. This is very critical. When it comes to wet line detection collision, you should use this blueprint a lot. Then it is in this pawn way. This is one of our preset files. We'll explain it to you when we get to this part later. And then, at this time, he also performed a static magic. Here he created static magic. Let's create a static magic. At the same time, in this magic, it attaches to this place, and here, it also uses his favorite way of writing this. Another way of writing this here, then if the loading is successful, let it use this resource. Then write it like this. He probably won't recycle it, because it might be, because it was a set of attachment by him. Yes, he also didn't expose it to the same file, so he just let him write it like this. Then we change it when we write it ourselves. This approach is not recommended. This is hardcoding. You can see, we demonstrated this path to you from the very beginning. We usually go through the main component. Components can be edited, and then it can be set in Blueprint. For writing it this way, it is only convenient during debugging, but in reality, it is very troublesome when reading. Moreover, once your project changes, once the location changes, this path becomes invalid, and it is also quite troublesome to look for bugs this way. It is very easy to fail to find them. Then here, it creates our example component. This method of it, the system of this example component is called movement particles. Note that it is attached to this static mesh component. Sphere is this component. You see? Because it is still in the constructor, this pointer is still valid, and it is not added to this root node. At the same time, it sets a simple offset. Here comes this classic writing style again. Classic writing style. Here, it finds a fire asset from our starter pack. It is set in here. Actually, these two steps, this step and this step. Actually, we should do both in Blueprint, which is more appropriate. But we don't care. We'll follow the example, and here a spring arm is created, then attached to something. We've done this many times before, so we won't focus on it here. Then a camera is created here and attached to the end of this spring arm. This is the actual camera. This is its actual camera spring arm component. Finally, it just needs to possess the player character for control. So overall, after construction, it has been scaled. So at this stage, it wrote roughly this much code. You can see in the constructed function, and at the same time, now it starts to connect the past and the future. It still follows the standard writing style. So here it does an action mapping. Is particle, meaning it uses spaces to do it. And here it's still on move 4. What is worth noting? Here the variables this x. We don't need to worry about this. Okay. So after finishing the mapping, so in this place, compared to the previous store difficulty area, it creates a movement component here. That is, we are not handling all movement. 微增第一次胖 it is handled through the movement component. This is a very good practice. Where is the movement component usually implemented? It essentially means that when you are not satisfied with the existing limited movement component, you can create a custom one to handle it. At the same time, because X on the movement synchronization already provides us with network synchronization, the synchronized data may not include the data you want. Perhaps during complex movement processes, I want to synchronize its acceleration or some of its rotation speed, some acceleration, or some direction-related aspects. It might not synchronize. If you synchronize every object for this direction and acceleration, that would be particularly good. Then you might need to do it yourself. Inherit this movement component. And then handle the packet sending and receiving yourself. And actually in the Lyra project. That's exactly what we did. And then here in Occas, we look for it because it is generally not a common class. Find this move component here. Then we directly calculate the pump movement component. Actually, when we develop, we make our third layer. We usually use character movement here for the convenience of demonstration because in most games, our player character may have jumping, crouching, pump, and these things. But if we are in a game like a card game or a tactical RPG, we might not need that many complex movements. Then you can adjust according to different needs. You can simply expand it based on its relationship. So this is a component-based approach. And actually, why is it called the fat movement component? It's because we take the movement functionality of the fat character and specifically write it into the component. Similarly, you can write the fat character's backpack component, right? The fat character's interaction component, the fat character's damage component, and various components for punk are all possible. This is to reduce the punk characters, in theory, during actual development projects. Within our punker character classes, we basically don't write much code at all. They mostly just serve as a forwarding layer. Even more so, after we use game feature, we can create a game feature like this. That is, when we need it, we attach a damage statistics analysis component to it. This kind of component, that is, how much damage this actor has dealt and who has dealt damage to it. It is essentially a damage history component. Therefore, using components is very powerful. We will discuss this later. And here, we have created such a movement component. Then, after having the movement component, we need to override some of its functions. Ideally, we only need to override this TickComponent, the part we originally implemented in the pawn. That is, we will receive an input value from the front end. So how is this input value mapped to the location and rotation of our act? We just need to take this part of the tick code and move it into the tick component of the movement component. You can see this is the tick component inside the component. It's just such a method. Then after defining it here, we override it. Naturally, we need to call the parent class, because the parent class may have some potential things that need to be executed. After execution, since this is a component, sometimes we are not quite sure whether our component is correctly attached to the object or whether it has received some other things. Receive these packets synchronized over the network. Whether to execute these synchronization functions. Then here we will let it make a simple judgment. After making the judgment, at this point, it will perform corresponding responses in processing here. You can see, here it first clears. It first obtains the set movement vector, then makes some judgments, then checks if it is non-zero, then checks whether movement is possible. If you don't perform this check, you might get stuck directly in the wall. That is, drill into the wall and clip through it. If we block these, we can make it slide past. That is, when you are against the wall. We play some games with Mombi. When you are against the wall. If that wall is not a long continuous wall, it might just be a corner. You get stuck. It can automatically do this. We call it slip or slide past. So here we made a simple judgment, and here are some comment codes, and here are the functions of these functions. Yes, and actually regarding this movement component, there should be a new movement component coming later, but it's not being used yet. We are still using the old movement component. So here we have actually completed our TickComponent detection, the process of installation and usage. After writing it, the code looks roughly like this. These two classes, at this point, we need to specify and mount this component. Obviously, here it declares one of our own components. Then, after we fill in the declaration here, we include its actual header file in our source file. And here we create this movement component. We can create an instance of it. Then at this point, in our move complement, we update this. We need to update a root node. We just need to specify it as this PAM's root node. Because it is not a scene component, there is a concept here. It is what I like to call, they are just components that handle logic, like inventory or damage, things like that. It is actually a logic component. It won't have an actual presence in the scene. So you don't need to do an attach here. You also cannot attach it, because only scene components are inherited. Our new component, only then can you attach such a parameter. And at the same time, we will have a method here that needs to be overridden. You need to tell this. You tell the engine here in this place, my movement component is this. After overriding this method, then actually this should be a virtual method or an interface method. We can click in and take a look later. Then we will demonstrate this in our GIS interface. That is to say, my class has this object. You need to call the function of my class. Call this get method of mine. Only then can you get this object to access the properties inside. Okay, so actually this plays perfectly. Writes our custom movement component for our point. So at this point, we have defined 4 methods. We want to respond to our front end. That is, to receive such data passed from our front end. So how do they respond? They do not define a variable on our point to receive this property. Instead, they forward it to our movement component. Note that I use the term forward to this movement component. Of course, before we forward, we need to do a null check in the middle. That is, we must ensure that this component already exists. Only then, and also update our root node, so it forwards it in here. And this value is the one we originally wanted to use for calculation. After forwarding it in, the movement component will know that you have added an input vector for me. Then I will process these inputs according to the rules I define to see if I can move there. So this is a method handled through the movement component. At the same time, this part handles its rotation, and this part doesn't need the movement component because it's an action factor. We directly trigger our particle, meaning our particle component exists. Because we only have the pointer to the same life, if you don't create an instance in the constructor, then this pointer is null. If you call a method on it, it will crash. And at the same time, this specified instance must also exist. Only then is it okay. And here's where we connect the previous part. We need to connect it. This part is actually the latter part, and here is the previous part. It's the same as the binding we did before. So after we write it like this, we are done writing. The final code should look like this, and when it runs, after that, it should look like this. Then it can perform collision detection with me and these. Perform some collision detection. That is, it can be correctly blocked or correctly slid against, and at the same time, it can trigger this particle effect. And here are some self-attempts we won't worry about. All right, we'll stop here for this document. Went through it once, a bit intense, but the intensity will be a bit greater later. We'll go through it in the next lesson.